Hello, boys and girls. Toto the Bear here with another problem of the week. Oh, sorry. I nearly swallowed the camera there. Anyway, I've no idea where Mr. Morrissey is, so I'm just going to start the lesson without him. Are you ready? Let's go! Whoopsie. Did it again. Right, let's get started with a recap of our recent learning. Now, so if you... how does this thing work? Let's see if I... What? Oh. Sorry, I'm not quite au fait with this bit of software. Whoopsie. Mr. Morrissey's not going to be very happy when he comes back. Hi, Tata, I'm back. What are you doing? Sorry, what's going on here? What's that on the screen? Did you start the lesson without me? Yes, I might have. Toto, that's not okay, and you've made a mess of it. Look at that mess on the screen. Can you just... Thank you. Can I sit... Just sit over there and stay quiet until I'm so... Oh, hello, boys and girls. I'm so sorry. Yeah, nothing to worry... Whoops. Okay, let's... Right, let's just get rid of that and... So last week, we were looking at adding fractions. And Toto asked you a big question. When you're adding fractions like these, 1/5 plus 2/5, why is the answer 3/5? So why do you add the numerators? 1 plus 2 equals 3, but the denominators don't change. Now, can you remember how we answered that question? We used unitising to help us, and unitising is when you're thinking very carefully about what you're counting, what your units are. So we know that 2 plus 3 is 5, so 2 cupcakes plus 3 cupcakes is equal to 5 cupcakes. And here we're counting cupcakes, there are units. And we saw that actually it's exactly the same with fractions like 2/5, so that's 2 of those jumps. You can think of 2/5 like that on a number line, and 3/5 is 3 of the same jumps. So 2 of those jumps or 3 of those jumps. So we're counting here 1/5, aren't we? We're counting 1/5. So if we're adding 2/5 plus 3/5, we can think of it as 2 1/5 plus 3 1/5 is equal to 5 1/5. You can see the 5 jumps of 5/5, isn't that right? Now, at the very end of the lesson, we did ask you about subtraction, so 2/5 minus 1/5. How would you think about that using unitising? And that's what this lesson is about. So for thinking about cupcakes again, we know that 2 cupcakes minus 1 cupcake is equal to 1 cupcake. You can see the 1 cupcake left over, can't you? So that's straightforward. And what about 2 cats minus 1 cat is equal to, well, 1 cat. You can see the 1 cat left over. So far, so good. What about fractions? Have you made the connection? What's this? How would you imagine it on a number line? Did you imagine it like that? 2 jumps of 1/5. So that's 2 1/5, isn't it? Minus 1/5. So it's 2 1/5 minus 1 1/5. What are you imagining? Did you imagine that? Taking away one of those jumps of 1/5, taking 1 1/5 away from the 2 1/5. And we're left with 1/1/5. So 2/5 minus 1/5 is equal to 1/5. You'll notice that just like we added the numerators and left the denominators the same with adding fractions, here we subtract numerators and the denominators don't change. Why don't the denominators change? We're counting 1/5. Our units are 1/5. Our answer has to be a certain number of 1/5. Here it's 1/1/5. How could we represent the same question in a bar model? That's my whole. What would I do with the whole? I split the whole into 5 equal parts. Why? Because we're working with fifths. We're counting 1/5. Fifths is all about splitting a whole into 5 equal parts. So the whole is 5/5. That's important. Now, 2/1/5. Why is that 2/1/5? There are 2 shaded parts out of 5 parts in total. And how would you show minus 1/5? How could you take away 1/1/5? Well, we could cross 1/1/5 out. And what's left? There's 1 shaded part out of 5 parts in total. 1 out of 5, 1/5. One final problem. A Chocolicious chocolate bar has 8 squares. Can you imagine that in your head? I bet you can. You eat 5 of those squares. Can you imagine that? I know you can. So you've eaten 5 squares, and there were 8 squares to begin with. So the question is, what fraction of the Chocolicious bar is left? How could you work that out? How could you think about it? How could you represent it? Why don't you pause and try to work out the problem yourself? I'll go through it now, if you're ready. I'm going to use the bar model, but I'm going to represent it in a slightly different way to before. So what's the same and what's different about this approach? A whole bar, a complete bar, has 8 squares. What are you imagining? What will my bar model look like? Were you imagining that? Here's my bar, and it's split up into 8 equal parts, 8 squares. You eat 5 squares. How could you show that? I'm going to show it like this. That's what I ate. That works because if I eat these, what I'm left with is what's left of the original bar. We call that the difference. The gap is the difference between the two numbers. So I'm using the difference model here to solve the problem. I want to find what that gap is. Now this is a fraction question. 3 or 3 squares. Is that the answer? No. What fraction of the original whole Chocolicious bar is left? So let's put some numbers, let's put some fractions into this. What subtraction number sentence goes with this? Our whole is 8 eighths because we had 8 squares and there were 8 squares in total. We had 8 out of 8 equal parts. So 8 eighths, that's our whole. And we're taking away what fraction? We ate 5 squares out of 8 in total. What's that as a fraction? It's minus 5 eighths. They're the squares we ate. They're all the squares in the whole bar. Does that make sense? And what fraction is left? Well, how many squares are left out of how many squares in total? It's 3/8, isn't that right? You can see the 3 squares and it's out of 8 squares in a whole bar. 3 out of 8 squares, 3/8. So that's the answer to our question. 3/8 of the Chocolicious bar is left. So you can find somebody to give the 3 squares to and make them very happy. Questions for you to do. The first one is here. I hope you can make that out. You're building up the subtraction fractions number sentence bit by bit. And then can you make up your own first then now number story? And the next two questions are here. For these questions I'm marking here, there is more than one correct answer. In fact, there might be quite a few correct answers. So how many can you find? And an extra super duper challenge would be, can you find every possible answer? You'd need to come up with some kind of a system so you know you found every solution. We call that working systematically, and it's really high-level maths there. So that would be some impressive mathematics if you took that approach. 3 problems here. Reading carefully, thinking carefully, applying what you know, applying your understanding of fractions, and choosing a good method each time. Are you ready for the answers? Now for the extra challenge, finding all those solutions, I think there were 6 possible solutions to that one, if you include 0/9, and 0 is a number, we must not forget 0. There were 7 for this, and an infinite number of possible answers for this one. So I hope you found every single one of those infinite number of solutions, did you? And some answers for our problems. I hope you feel proud of your work with those. That is it for this lesson. I hope you enjoyed it. Before we finish, Tao Tao did want to say a few words. Didn't you, Tao Tao? Come on. So, what did you want to say?
Sorry for being so silly.
Thank you. And you promise you'll never do that again, isn't that right?
I might never do that again.
Whoopsie.